So, an important topic in physics is keeping track of where you are, and this is called position. And there are really two fundamental ways we commonly define position. So these two ways are displacement and distance, and I'm going to spend this video discussing the difference between the two. So I'm going to use an example to illustrate this difference. Say we have a track that's 100 meters around, okay? And we have a starting line, and we have a runner at that starting line. And now this runner runs around the track, okay? So now we can ask, what is the runner's position? And the two ways we measure this is, what is his displacement, or what is his distance? So we'll start with distance, because this is actually the more common way to think of it, especially on a track. We would say the runner's distance, which I'm going to call little d, equals 100 meters, okay? And the reason for this is the runner went 100 meters. He ran all the way around the track. That amounts to 100 meters of distance covered, okay? So then we can ask, what is the runner's displacement? And displacement measures change in position. It's really important because a lot of physics is about measuring types of change. So this measures a change in position. So we can ask, what is the runner's change in position? Well, he started here at the starting line, and he ended at the starting line. So that means his change in position is 0. I know it may seem counterintuitive, but that's actually what displacement measures, okay? So it's common to denote displacement with the variable x. So I'm going to call it x equals 0. Okay? So let's continue this example a little further. Now let's make a bigger track. Now the track is going to be 200 meters. And our runner is right here at the starting line. Except now, instead, he's going to run all the way around. But now he's going to run another half lap, okay? So he's going to end on the opposite end of the track. And the distance from one end of the track to the other across the middle here is 20 meters, okay? So now we can ask, first off, what is the runner's distance? What distance did he cover? D. And, well, let's think about this. It's a 200-meter track. He went all the way around once, so that's 200 meters he covered already. But now he went an extra half lap, so half of 200 is 100. So actually his total distance is 300 meters. Okay? Now let's think about his displacement. This is a little bit different. Okay? So what is x? Well, he isn't where he started, right? He started here, and he ended down here. So he's not at the starting line, so his displacement isn't 0. It's actually 20, okay? And that's because you just measure the distance between the 2 points, which is the straight line through the middle of the circle, okay? So his displacement is 20 meters, but his distance is 300 meters. And I hope you see these are two very different ways about talking about position. But they're both useful in their own way. When we talk in kinematics, a lot of times we talk about displacements because displacements measure changes in position. And in physics, we're often just interested in changes, not how something went through the change, whether it went around a bunch of circles and ended up on the other end of the track or not. We just want the end result that, okay, it ended up 20 meters away from where we started. Whereas distances are something we are more commonly use in everyday life because they're more meaningful. When you run a mile around a track, you don't tell someone, I ran and my displacement was 0 meters. No, you tell them, I ran a mile. And that's because the measure of distance is the more relevant quantity there. But they're both important quantities, and it's important to understand the distinction. Because later on, these quantities are used to compute how we change our position in time, which is movement, and it's very different if you're measuring movement in context of distance versus in context of displacement. And I'm going to elaborate more on this in the next video.